Hello and welcome to this video tutorial on 123D Make. In this video I will show you how to produce a simple desk tidy or wall storage project. The topics covered in this video are drawing the base model in Autodesk Inventor, exporting the model to an STL file and opening it in 123D Make, setting up the required material, applying the construction technique to be used, editing the slice direction, demonstrating the assembly steps, and exporting the plans to DXF for fabrication. In Inventor, I'm going to create a new sketch. I want the desk tidy to extend 100mm from the wall, so I will draw a vertical line 100mm long. The diameter of the finished object is 700mm. I'm going to revolve this shape, so I will draw a horizontal line 350mm long. I will then draw an arc between the two endpoints of the line. With the shape drawn, I will now revolve it. This forms a spherical dome shape and is the only modelling that I will have to do in Inventor. I will now export it to an STL file so that it can be opened in 123D Make. In 123D Make, the first step is to import the model that was drawn in Inventor. To do this, click Import and find the STL file. The first thing that should be done is to rotate the object to the correct orientation. This particular model imported with the back as the top, so I'll press the rotate button until the correct orientation is found. Use the view cube here to check the orientation. The material that I'm using for this project is 3mm acrylic. I will select this in the drop down menu. At this stage you can edit the material thickness and the sheet size at the bottom of the screen if required. I'm going to set the units as centimeters here, as when imported from Inventor the units are centimeters instead of millimeters. I will now check the original size box, which changes the sizes of the model to dimensions as drawn in Inventor. With this done, I will now apply the construction technique. For this particular project, I will use the interlocked slices construction technique as I want the cubbyhole effect. When interlocked slices is selected, the slice direction may come in the wrong way. Therefore, the slice direction option must be used to change it. To do this, I am moving the orange circle from one axis to the other. Note that I move it to the intersection of two axes to ensure that the interlocked slices are at 90 degrees. You may have to move the blue cone as well, depending on how you want the finished product to look. Use the up and down buttons to increase or decrease the number of slices on each axis until you get the required appearance. Assembly steps can be used to show you the way in which the model goes together. This particular model does not require any further modifications, so I'm just going to go ahead and get the plans. The laser cutter that I'm using requires a DXF drawing, so I'm going to export it to DXF. Notice that I'm using millimeters here as the unit rather than centimeters. I found that if I set it to centimeters here, I would have to scale it again in AutoCAD to get it to the right size. Once you're in AutoCAD, you may need to move around some parts if 123D Make didn't nest them in the most efficient way possible to get the best use out of your material. In AutoCAD, the first thing that I will do is edit the lines on each part. When the parts are imported from 123D Make, they are made up of a number of short lines. The laser cutter that the parts will be cut on prefers a single geometry for each part. Therefore, the join command will be used to create a single geometry. To join them, all the parts can be selected at the same time after clicking the join command, which is located in the Modify tab on the ribbon. Press enter when finished. This creates a single geometry for each part, known as a polyline. I will then use the move command to move the parts as close together as possible to make the best use of the material. I will now move the box representing the outline of the sheet back around the parts. This is useful as it allows you to calculate the amount of material required to produce the project.